So far in 6.1, we've looked at functions that are continuous over their entire domain. The method that we've used for determining general solutions are only valid for continuous functions. So if we want to find a general solution or a particular solution for a function that is discontinuous, we need to restrict the domain to the continuous portion of the function that contains the particular solution. So in example 4, we're going to look at just that. Determine the particular solution to dy dx equals negative secant squared of x, whose graph passes through the point 0, 3. So we know secant squared is discontinuous because there's specific x values that'll make it undefined. The x values that will make secant squared undefined would be the values that make cosine 0, since secant is the reciprocal of cosine. Fortunately, we don't really have to worry about the domain until the very end. These problems start just like the previous ones. So we're going to write dy dx is equal to negative secant squared of x. And we're going to multiply both sides by dx. And we're going to get dy is equal to negative secant squared of x dx. We integrate both sides with respect to each of their variables, and you get y is equal to the derivative of tangent is secant squared, so the integral of secant squared is going to be tangent. So it's tangent of x plus c. Now what we're going to do is we're going to use our particular value, which is 0, 3, to determine the value of c, negative tangent of 0 plus c. And we know tangent of 0 is 0, so 0 plus c. So c is equal to 3. So our general solution for this problem would have been y equals negative tangent of x plus c, and our particular solution is y equals negative tangent of x plus 3. The last thing we need to do is to restrict the domain, and so we need to look at secant squared, which looks something like this. And what we need to do is restrict it. So let's think. Our x value is 0. So I know that secant squared of x cannot equal 0. So let's find the x values that make this true. So I'm going to write cosine squared of x equals 0. Cosine of x equals 0. And x is going to be pi over 2 plus n pi. So pi over 2, 3 pi over 2, and so on. So the value 0 is going to be within the domain values of negative pi over 2 to pi over 2. That's the domain for that particular solution. So what I want you to try now is another one. So I want you to try to determine the particular solution of dy dx equals negative 1 over x squared minus 3 over x to the 4th plus 12 and passes through the point 1, 3. So here we go. Dy dx is equal to negative 1 over x squared minus 3 over x to the 4th plus 12. I recommend to write this with negative exponents to make the integrating easier. Now we're going to multiply both sides by dx. And we get dy is equal to negative x to the negative 2 minus 3x to the negative 4 plus 12 dx. Now we integrate both sides and we get y is equal to negative x to the negative 1 divided by negative 1 minus 3x to the negative 3 divided by negative 3 plus 12x plus c. This is the same as writing y equals 1 over x plus 1 over x cubed plus 12x plus c. Now we're going to use our value of 1, 3. And we get y is equal to 1 over 1 plus 1 over 1 cubed plus 12 times 1 plus c. Y is equal to 1 plus 1 plus 12 plus c. Y is equal to 14 plus c. And our y value is 3. So you get 3 is equal to 14 plus c. So c is equal to negative 11. So our particular solution is y equals 1 over x plus 1 over x cubed plus 12x minus 11. And the domain, we have to think for a minute. Go back to our original function, and we see that x equals 0 does not work. So then we say x cannot be 0. So the question is, does our point 1, 3 lie when x is less than 0 or when x is greater than 0? And 1, 3 is when x is greater than 0. And so that is our answer.